Hey y'all, in this video we're going to be taking a look at geometric sequences, which are similar to arithmetic sequences. By the end of this lesson, we want to be able to say, I can understand and represent geometric sequences. So, we are going to ask the essential question, highlighted here in yellow, how are geometric sequences related to nonlinear functions? Arithmetic were related to linear functions, geometric will be related to nonlinear functions. The only additional vocabulary we have is how to define a geometric sequence. So the definition of a sequence is still the same, but a geometric sequence is going to have the ratio of successive or consecutive terms is the same. This is called the common ratio. So a geometric ratio has a common ratio, and the common ratio is the ratio from one term to the next. Let's look at our first example identifying a geometric sequence. In this example, we can see that we have a few pieces of information about how high a bouncy ball has bounced on each of it. So you bounce it, and it bounces once, and then twice, and then 3 times, each time not bouncing quite as high as the previous time. And we can see those heights represented here as 200, 80, and 32. What we want to do is look from one term to the next, and instead of asking how much is added or subtracted, like we did with arithmetic sequences, we want to look at how much is multiplied. So we see going from 200 to 80, we're going down, or a smaller number, which means we are multiplying by a fraction. And we want to figure out what is that fraction. In this case, that fraction from 200 to 80, or from 80 to 32, is going to be 2/5. How do we figure that out? We can figure this out. We can figure out the common ratio by taking a term and dividing it by the previous term. So if you take 80 and you divide it by 200, 80 over 200, or 8 over 20, reduces to 2/5. So that is how you figure out the ratios. You take one term and you divide it by or write it as a fraction over the previous term. So the height of the bounces shown in the table do form a geometric sequence with a common ratio of 2/5. So again, we're going to look at finding the next 3 terms of a geometric sequence. Here we have 1, 4, 16, 64. How much are we multiplying by from one to the next? If it's not easy to see, what we can do is we can take the second term 4 and divide it by the first term of 1. So 4 divided by 1 is 4. So we're multiplying by 4. That means that the common ratio is 4, so we continue multiplying by 4 to get the next 3 terms. The next 3 terms will be 256, 1024, and 4096. Again, to find the common ratio, you take a term and divide it by the previous term. You try. Find the next 3 terms in that geometric sequence. Keep in mind that when terms in a geometric sequence alternate between positive and negative, like this one, the common ratio will be a negative number. So try to find the common ratio as well as the next 3 terms. Pause the video, do your work, and press play to see the answer. In this problem, we are multiplying by a factor of -2. Our common ratio is -2. That means that the next 3 terms are going to be, we're going to continue by multiplying by -2. So -40 times -2 is +80. That times -2 is -160. And that times -2 is +320. These are the next 3 terms of this geometric sequence. Now that we know how to identify a geometric sequence, let's go over a couple of key things. Geometric sequences are non-linear. They are not changing by a consistent rate. They can be represented by an equation in the form of y equals a times b to the power of x. So in this case, the value a is going to be the first term divided by the common ratio. And the value b is going to be the common ratio. Similar to arithmetic sequences, the term number or the position in the sequence, first, second, third, and so on, is the input of the function, and the term itself ends up being the output of the function. Let's look at an actual example writing an equation for a geometric sequence. Here we can see again the position first, second, third, fourth in red, the term itself 3, 6, 12, 24 in blue, and again I already explained that those A with the number in the bottom corner is another way to write first term, second term, third term, and fourth term. We need to identify what the sequence starts with, what is the common ratio. We'll use those to find our values of A and B, and finally write our equation. In this example, the sequence starts with the number 3. As we go from 3 to 6, 6 to 12, and 12 to 24, we are multiplying by 2. So our common ratio is 2. This means that our value of A is the starting value 3 divided by the common ratio of 2. Put 3 divided by 2 into a calculator and you get 1.5. The value b is the common ratio itself, so it will be 2. So now we use the equation y equals a times b to the power of x, and we write y equals a, 1.5, times b, 2, to a power of x. And it looks like this. Again, these are nonlinear functions. We have not been working with these, so this should look new to you. Remember that when writing a function rule for a sequence with a negative common ratio, you will want to use parentheses. This is because a negative 2 to the power of 12 is not the same as that negative 2 in parentheses to the power of 12. So if you have a negative common ratio, in this case we had 2, but if we had negative 2, you'd want to use parentheses to help show that the common ratio is negative 2. You try writing a rule for this sequence, 3, 15, 75, 375. What is the common ratio? And use that to help write your equation. Try this on your own by pausing the video, then press play to see the answer. In this problem, we end up getting a common ratio of 5, and our first term divided by the common ratio is 3 divided by 5, or 3/5. So our equation is y equals 3/5 times 5 to the power of x. To summarize, a geometric sequence, like an arithmetic sequence, is a sequence of numbers that follows a pattern. In this sequence, though, the pattern is that the ratio between two consecutive terms is a constant called the common ratio. A ratio is a fraction. It is multiplying. We use the form of y equals a times b to the power of x to write an equation, where a is going to be the first term divided by the common ratio, and b is the common ratio. Make sure to complete the summary in your notes. Your next steps are to submit your 7.5 notes, complete your 7.5 practice on paper in your packet, then submit a photo of that to the 7.5 practice, and finally to your 7.5 mastery check. Good luck, and I'll see you in the next lesson.